Okay, we're going to have a look here at how we handle simple division with surds. I've got here a fraction, 8 over the square root of 2, 8 over root 2. To simplify this fraction, what I'm going to do is try and get rid of the irrational number down here in the denominator. What could I do to get rid of that root 2, to get rid of the irrational number down there? Well, I could multiply root 2 by root 2, because that's going to end up as 2. But of course, to maintain this fraction, I can't just multiply the denominator by root 2. I have to do the same to the numerator. So I'm multiplying by root 2 over root 2, which is the same as multiplying by 1. So I'm not changing anything. So let's see how that pans out. If we multiply our numerators, we're going to get 8 root 2, 8 times root 2. And if I look at multiplying our denominators, root 2 times root 2 equals 2. I can do a little bit of cancelling here as well, because I've got there a 2 in the denominator and an 8 in the numerator, so I can cancel that, leaving a 4 there. So our final answer is 4 root 2. So actually, I don't have a fraction anymore. What I set out to do was to take the irrational number out of the denominator, but I've actually taken everything out of the denominator. This process is known as rationalising the denominator. And all rationalising means is taking this irrational number out of it. And it's a convention in surds that whenever we see a fraction that has a surd in the denominator, we need to take it out. Let's have a look at another example with that in mind. 1 over 3 root 3. So just like we did before, what can we do to 3 root 3 in order to deal with the fact that we've got an irrational number there? Well, we can multiply it by root 3. But again, we need to multiply the numerator by root 3 as well. So we maintain the fraction, we don't change it. So what have we got? 1 times root 3 is root 3 over what's happening in our denominator. 3 times by root 3 times by root 3. Root 3 times root 3, that's 3. So root 3 over 3 times by 3 over 9. That's how we would rationalise or remove the irrational part of rationalise the denominator.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.